Good morning, children.
Good morning, ma'am.
Good morning, ma'am.
Good morning, children.
Good morning, ma'am.
Good morning. We finished this one yesterday, right?
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. So this is the next one. This is the last one in exercise 7.1. Yeah, see the details given about the figure. Okay. So what kind of a triangle is triangle ABC?
Right angled triangle.
Right angle.
Yeah, it's a right triangle. And which vertex measures 90 degrees in ABC?
Ma'am, angle C.
C.
Angle C. So see, angle C means right triangle
Ma'am, angle
ABC.
ACB. Ma'am.
This is the right triangle ABC. ABC. Right angle at C. This full thing is 90 degrees. Just because there's a line going through like this, it doesn't mean that this is 90 or this is 90. This full thing, this entire thing is 90. This angle ACB is 90 degrees. Angle ACB is 90 degrees. Okay. And M is a point on the hypotenuse AB, right?
Yes, ma'am.
Okay. M is a point on AB. Is M a point on DC?
Yes, ma'am.
M is a point on AB. Is M also a point on DC?
Yes, ma'am.
Yes, ma'am.
Yes.
Ma'am.
Yes, because AB and DC, they meet at M. AB and DC, they meet at M. So M is a point common to both AB and DC. M lies on AB. M also lies on DC. Now what is given there? M is the midpoint of the hypotenuse AB. So M not only lies on AB, it's also the midpoint of AB. So what does that tell us? If M is the midpoint of AB, which are the two line segments that are equal? If M is the midpoint of AB, then which are the two line segments that are equal?
AM and BM. Ma'am.
AM is equal to BM. AM is equal to BM. This is AB. This is AB. M is the midpoint of AB, which means AM. AM is equal to BM. All right. So we have a right triangle ABC, right angle at C. M is the midpoint of AB. So see here, let's draw the figure. M is the midpoint of AB. So this is M, okay? This is M. I started. This is the right triangle ABC, right angle at C. M is the midpoint of the hypotenuse AB. Am I audible, children?
Yes, ma'am.
Yes, ma'am.
Okay, now C is joined to M. Read the question ahead. Read ahead. C is joined to M. C is joined to M. And produced to a point D. And it's produced to a point D. C is joined to M and produced to a point D such that DM is equal to CM. DM is equal to CM. What does that mean if DM is equal to CM? If DM is equal to CM, it means if DM is equal to CM, what does it mean?
They are
M is the midpoint of line DC.
M is the midpoint of
D and C.
Line DC, ma'am.
not D and C, of the line segment DC.
DC.
So M is the midpoint of both AB and DC, isn't it?
Yes, ma'am.
Yes, ma'am.
M is the midpoint of both AB and DC. Point D is joined to B. So see here, point D is joined to B. This is how you get this figure. So sometimes the figure may not be given. So how do we draw? Right triangle ABC. See, if it's not given, then you will not know that you have to take a triangle like this. Then you can even draw like this. Right triangle ABC. If the figure is not given, ABC, right angle at C. So right angle at C. Right triangle ABC, right angle at C. M is the midpoint. M is the midpoint of AB. C is joined to M. I'm reading the question, children. C is joined to M. C is joined to M. C is joined to M. And produced to a point D. It's produced to a point D. It's produced to a point D such that DM is equal to CM. DM, see this DM is equal to CM. To that extent it is produced. It's produced to that extent so that CM is equal to DM. Then point D is joined to the point B. You can also draw it like this. If the figure is not given, then you can also draw it like this. So from the information given, we understand that ABC is a right triangle, right angle at C. M is the midpoint of AB. M is also the midpoint of CD. So known all this, we need to show that the two triangles AMC and BMD are congruent to each other. AMC, where's AMC? This one, AMC. This one, AMC and BMD. BMD. We need to show that these two triangles are congruent to each other. Yes. List out the equalities, in these two triangles. Please tell me like this. So some side of triangle AMC is equal to some side of triangle BMD. Yes.
Ma'am, you have to prove no, ma'am.
Yeah.
I'm using SCI.
Yes, Pranav. Tell me the first equality.
Ma'am is M is the.
You should write you must write an angle is equal to another angle or a side is equal to another side. M is the midpoint. All that is not.
Yes, yeah. BM is equal to AM.
BM
Angle.
of which triangle? BM of which triangle? I told you. The
BM of ma'am, DBM, ma'am.
BM of triangle DBM is equal to?
Triangle of AMC, in which AM, ma'am.
Is equal to AM of triangle AMC. Why?
Yes, ma'am.
Why?
Ma'am.
Why? Reason?
Are parallel, ma'am.
Because it is divided by half, ma'am. The product is the produced line is divided into half, ma'am.
See the information given and tell me more clearly. Why AM is equal to BM?
No, because M is the midpoint. M is the midpoint, ma'am.
Because
Ma'am, M is the midpoint and it is divided into two, ma'am, DM and CM. So only.
This is
Ma'am,
the.
because.
Yeah, because.
Because M divides BM and MA into equal angle, ma'am. Both equal angle.
Angles, huh?
I'm sorry, ma'am. Sides, ma'am. Side.
Okay, so this side is equal to this side. Next. Next.
Ma'am, AC is equal to BD, ma'am.
AC is equal to BD. Reason. Reason. Please have the reason before you say something, children.
Ma'am, both are
Either it should
parallel
be given.
lines of.
Okay, see, I got two parallel lines, okay? This is.
Ma'am, in the question they are given M is the midpoint of the hypotenuse, so these both lines are.
Sorry? Yeah, Shreyas. See,
Ma'am,
these two lines are parallel. Then can you say that AB is equal to CD?
Ma'am,
no, ma'am.
And it's not given also that AC is parallel to BD. How can you say that? Incorrect, Shreyas. Your justification is incorrect. You should be able to justify it.
DM is equal to CM.
Ma'am, DM is equal to CM.
DM is equal to
CM, ma'am.
reason?
Because M is the midpoint and they are parallel.
Because M is the Shivani, you tell me. Because M is the
Midpoint, ma'am. Midpoint of DC.
because M is the midpoint of DC. Somebody's mic is enabled. Please disable your mic. Okay, then one more.
Ma'am, CMA is equal to DMB.
CMA is equal to Pratiksha, is it?
Yes, ma'am. CMA is equal to DMB.
Reason?
Ma'am, they are vertically opposite angles.
Vertically opposite angles are equal. So what rule does it make, Pratiksha?
Ma'am, SA is congruency.
Very good. By SA's correct. By SA's congruence condition, the two triangles are congruent to each other. AMC is equal to AMC is equal to BMD by SA's congruence condition or congruence rule. Next one. Prove that angle DBC is a right angle. DBC is a right angle. Just a second, children.
Yes, ma'am.
Yeah. So the two triangles are congruent by the SA's congruence condition. Now next one, we need to show that angle DBC is a right angle. DBC. You need to show that this is a right angle. You need to show that angle DBC is equal to 90 degrees.
Ma'am, since angle MAC is equal to MBD by corresponding parts of congruent triangles, ma'am.
Okay.
Then, ma'am, that line AC is parallel to DB, ma'am.
Okay.
They form alternate interior angles, ma'am.
Correct.
Now that, ma'am, now BC is a transversal, ma'am, which intersects AC and DB, ma'am.
Correct.
So, ma'am, now the angle name, ma'am, BCA plus angle DBC is equal to 180 degree, ma'am.
Correct. Correct. Why?
Ma'am, both are allied angles are co-interior angles.
Perfect. Correct, Shreyas, you're right. So angle DBC is equal to 90 degrees. Perfect. All right, children. So how do we name? I told you, you should name the congruent triangles in the correct order. So when you say AMC, you have it here. AMC, it's BMD. So that means vertex A goes with vertex B. Vertex A of triangle AMC. This is vertex A of triangle AMC. This is vertex A. See here, triangle AMC. Vertex A corresponds to vertex B of the other triangle. This is vertex A of triangle AMC. And this is vertex. And this is vertex B. This is vertex B of triangle BMD. See, BMD, vertex B is not the full thing here like this. B of the triangle BMD. This is triangle BMD. This is the triangle BMD. This is the triangle BMD. So vertex B is only this part. Only this part. So since the two triangles are congruent to each other, angle A, or you can mark this angle 3, is equal to angle 4, CPCTC. Angle 3 is equal to angle 4. We proved that, we proved that the two triangles are congruent to each other. So now that they're congruent, angle 3 is equal to angle 4, CPCTC. Corresponding parts of congruent triangles are congruent. But if you see, angle 3 and angle 4 are alternate interior angles. See here, angle 3 and angle 4, angle 3 and angle 4 are alternate interior angles. Angle 3 and angle 4 are alternate interior angles. See here, these are the two lines, and this is the transversal. Angle 3 is equal to angle 4. We know that 3 is equal to 4, but 3 and 4 are alternate angles made by these two lines and this transversal. So that means this line is parallel to this line. Because only when a transversal intersects two parallel lines, alternate interior angles are equal. Only when a transversal intersects two parallel lines, alternate interior angles are equal. So now we know that 4 and 3 are equal and they're alternate interior angles. So that means the lines must be parallel to each other. Therefore, AC is parallel to DB. AC is parallel to DB. So now that AC is parallel to DB, this is DB, this is BC, this is AC. Here, this is DB, DB, this is AC. So now we prove that this is parallel to this. This is 90 degrees, is already known to us. So now DB is parallel to AC and BC is the transversal. AC is parallel to DB and BC is the transversal. Allied angles are supplementary. And this is 90. So this has to be 90 degrees because 90 plus 90 is 180. Allied angles are supplementary. So if this is 90, this has to be 90. So this way we show that angle DBC is equal to 90 degrees. Next, how do you show that triangle DBC?
Ma'am, ma'am, in the first we have proved that AC is equal to BD. No.
There's 1 minute. Let me just ask somebody else. I'm happy that you know it. Let's just see if someone else can answer.
Okay,
Yes,
ma'am.
yeah. Yes, children think DBC and ACB. DBC. This is DBC. And this is ACB. DBC. A C B. We proved that DBC is 90, so let's mark that. We already know ACB is 90. What else we have? We need to show that these two triangles are congruent to each other. Take the triangles separately. Draw them. Take them individually like this DBC and ABC. Mark off whatever you know about the two triangles. Yes, Shreyas is ready with the answer. I want somebody else to try. Okay, tell me the obvious one. Something is already there, no? Tell me that.
90 degree. Angle 1 is equal to angle 2.
Angle 1 is equal to angle 2 is equal to 90 degrees. Then one more obvious thing.
And BC is common.
BC is the common side. Both the triangles stand on the same base BC. If you look at the figure given in the question, both the triangles DBC, ABC or ACB, DBC, ACB, BC, BC. This is BC, this is CB. Here, DBC, ACB. Both of them stand on the same base BC or CB. So BC is the common side. Okay. Common side then. Both are right triangles. Can we use RHS?
Yes, ma'am.
To use RHS, what is that information which you need? Do you have R for right angle? We have it right. Angle 1 is equal to angle 2 is equal to 90 degrees. Then H. H is hypotenuse. Yeah. Which is the hypotenuse in the first triangle, DBC?
DC is the hypotenuse.
DC, ma'am.
Which is the hypotenuse in the other triangle, ABC?
AB, ma'am.
AB.
Second triangle. Do you know that the hypotenuse DC is equal to the hypotenuse AB?
No, ma'am.
No,
Then
ma'am.
we cannot use RHS. If we don't know that, if that's not given, or we cannot prove that, you cannot use the RHS rule. Because RHS is right angle, which we have. Angle 1 is equal to angle 2 is equal to 90 degrees. Hypotenuse. The hypotenuse DC should be equal to the hypotenuse AB. Only then you can use RHS. S we have. S, some other side, any side. BC is equal to BC, common side. So we have R and S. We have R right angle and S some other side we have BC is equal to BC. But hypotenuse DC equal to hypotenuse AB is not known as of now. So we cannot use RHS. What else? What other rule can you use? Can you use SSS?
Ma'am, no, ma'am. We can use SAS, ma'am.
What are the options are available? SAS or?
Ma'am, RHS we can't use. Yes.
Yeah, RHS we cannot use. SSS we cannot use.
Ma'am, ASA.
ASA. For that, you have to show that these two angles are equal. If you want to use ASA, then you have to show that this angle is equal to this angle. Only then it will make ASA. Angle, side, angle. Angle, side, angle.
Ma'am, I think we can use SAS alone.
SAS, huh? So then you
Yes.
should prove that, yeah, then you should prove that this side is equal to this side if you want to use SAS. You must show that DB is, because for SAS, this is the only option. SAS, you should show that DB is equal to AC. But DB is not equal to AC, it's not given.
First,
Ma'am,
yes, angle ANC is congruent to angle B and D. So by CPCD, we can also write that AB is equal to AC. So we can use that proof here.
Okay, Sangamitra. Yeah, thank you. So since we've already proved that these two triangles are congruent to each other, we've proved that this triangle is congruent to this. See the first one. So from this we have AC is equal to BD. Excuse me. AC is equal to BD. See here, these two triangles are congruent to each other. So AC is equal to BD. CPCTC. So that's the reason here. AC is equal to BD because triangle AMC. Because triangle AMC is congruent to BMD, CPCTC. So by SAS rule, the two triangles are congruent to each other. DB is equal to AC. In these two triangles, DB is equal to AC because AMC is congruent to BMD, CPCTC. Then angle 1 is equal to angle 2, 90 degrees. BC is equal to BC, common side. So by SAS rule, the two triangles are congruent to each other. So now that they are congruent, their hypotenuse AB and the hypotenuse here DC will be equal. AB is equal to DC. AB is equal to DC or DC is equal to AB. DC is equal to AB. CPCTC. Since the triangles are congruent, their hypotenuse are equal. DC is equal to AB. Divide by 2 on both the sides. DC by 2 is equal to AB by 2. Is equal to AB by 2. Divide both the sides by 2. What is DC by 2? What is DC by 2?
It is DM, ma'am.
Or CM is equal to AB by 2. That's nothing but half AB. AB by 2 is nothing but half AB.
AM or DM?
No. Here they have retained half AB as it is. So write it as it is.
Okay.
So to prove the last one, CM is equal to half AB. To prove the last one, CM is equal to half AB. Write DC is equal to AB. Hypotenuse equal in the congruent triangles. DC is equal to AB. Okay, DC is equal to AB. Then divide both the sides by 2. DC by 2. DC by 2 is equal to AB by 2. DC by 2. DC by 2 is DM or MC. But we'll write MC or CM because that's what we have here. So we'll write CM. CM is equal to we'll not disturb AB by 2 because on the other side we have half AB only. So let it remain half AB, let it remain half of AB. So like this we prove that CM is equal to half AB. Yeah, this proof, I want all of you to write it now in the class.
Ma'am, but I already copied while you said no.
You can practice if you want again, or if you're sure you know it well, you can leave it. Wait. Okay, if it's going to be like some of us have finished the notes, some of us are not finished, go through the proof carefully and get your doubts clarified.
Ma'am?
Yeah.
Ma'am, you are asking some question, ma'am, while discussing the answer. On the time, my network was slow, ma'am. It's having some issues, so I don't know what's that question was, ma'am.
Shivani, you go through this proof and you ask me if you have any questions.
Okay, ma'am.
Yeah, please go through this proof, and if you have any doubts, you can get it clarified.
Yes, ma'am. Thank you, ma'am.
Yeah.
Ma'am?
Yeah.
Ma'am, can you explain the fourth one?
The fourth one, huh? What was that? CM is equal to half AB, right? Okay. Now, these two triangles are congruent, right?
Yes, ma'am.
See here. Do we understand this?
Yes, ma'am.
Triangle DBC congruent to triangle ACB. This one we understood?
Yes, ma'am.
Okay. So now, when DBC is congruent to ACB, DC is equal to AB, correct?
Yes, ma'am.
Why DC is equal to AB?
By corresponding parts of congruent triangles.
Pratiksha, why DC is equal to AB?
Ma'am, because DBC is equal to ACB.
Because DBC is congruent to ACB, their corresponding sides are equal, correct?
Yes, ma'am.
Okay, now divide both the sides by 2. You can do the same operations on both the sides. When you divide now this is an equality. DC is equal to AB is an equality. When you divide the LHS by 2, divide the RHS also by 2. So that way you will not be disturbing the equation. So dividing both the sides by 2. So DC by 2. DC, or you can say half of DC. If DC is equal to AB, half of DC is equal to half of AB. When two things are equal, their halves also will be equal, right? When two things are equal, their halves also will be equal. So now, Pratiksha, what is half DC? What is half of DC?
DM.
Or MC, right?
Yes, ma'am.
Yeah, but what is needed? What is here? You need to show that CM is equal to half AB. So half DC is DM or it is MC. But you write whatever is needed here. MC, right? MC. Half
Yes,
of DC is MC. Half of DC is MC is equal to. Is this understood?
Yes, ma'am.
Now half AB, write it as it is because that's what you have. Here we have half AB as it is. So don't change this, right? Half AB as it is. So like this, we have MC is equal to half of AB.
Yes, ma'am. Now I understood.
All right, yeah.
Thank you, ma'am.
You're welcome.
Finished copying.
All right. Yes, children, any questions?
No, ma'am, that's clear.
No, ma'am.
Yeah. E and F are respectively the midpoints of equal sides AB and AC of triangle ABC. Show that BF is equal to CE. So to show that BF is equal to CE, you need to take up one triangle which has BF as a side and another triangle which has CE as a side. Tell me a triangle which has BF as a side.
Ma'am, ABF.
ABF.
ABF. Another triangle which has CE as a side.
CEB, ma'am.
CE.
CEB.
But since
Ma'am, CEA.
CEA, yes, you must be able to see, you must be able to gauge if you can show that the two triangles are congruent to each other. You cannot take some two triangles. Here, two triangles have the sides. Two triangles have side BF and two triangles have side CE. So you must be able to take the two triangles carefully. So now one pair can be
AE, ma'am.
BF in triangle ABF. BF in triangle ABF. If you take ABF, if you take this triangle ABF, then C must be taken in triangle ACE, this one, ACE. If you choose ABF, then you must go with ACE. And you can make out, you can prove that these two triangles are congruent to each other. If you take ABF, this triangle, then you must take AEC or ACE, this triangle. In ABF, we have BF and ACE, we have CE. So if you show that these two triangles are congruent to each other, then CPCTC, you will get BF is equal to CE. Else, if you take CBF, triangle CBF, then you must take triangle CEB. You must take triangle CEB. The two triangles with the base BC. You must take the two triangles with the base BC. If you take CBF, then you must take, excuse me. If you take CBF for BF, then you must take CBE for BE, for CE. Now tell me which are the triangles. We can take up two pairs of triangles and show that they are congruent to get this result BF is equal to CE.
Ma'am,
ABF.
BEC.
Come again.
Ma'am, triangle BFC is equal to triangle BEC. Congruent to triangle BEC like this.
Okay, so he wants to take up BFC. BFC. Hitesh, tell us BFC and BEC. Yeah. Tell me one equality in these two triangles.
Ma'am, C.
BFC, which is the triangle BFC? This one. BFC. And BEC is this one. Yeah, you can see the triangles BFC, BFC and BEC. BFC, BEC.
Ma'am, BC equal to BC, ma'am.
Yeah, BC. Both the triangles stand on the same base BC. So BC is equal to BC, common side. Then
Ma'am, BF is equal to C.
what should be proved, Shreyas? What is that we are trying to prove?
Ma'am, sorry, ma'am. BF is equal to C only, ma'am.
Yeah.
Ma'am, B is equal to FC.
Reason. Is AB equal to AC, children? Is AB equal to AC?
Yes, ma'am.
Yes, ma'am.
Equal to AC. So half of AB will be equal to half of AC, right?
Yes, ma'am.
What is half of AB? You can write half of AB only if you know its midpoint. Otherwise, you cannot write. When you can write
Ma'am,
half
half of AB is
Point.
EB.
you can write half of a line segment only when you know its midpoint. Otherwise, we cannot write simply half of any line segment. We cannot write. You can write half of something only when you know the midpoint. And what is E? E is the
Midpoint of
midpoint of
AB.
Midpoint of AB.
AB. And what is F?
Midpoint of
Midpoint
AC.
of AC.
Midpoint of AC. So you know E is the midpoint of AB. So you can write half AB. What is half of AB?
EB.
EP.
What are the two halves of AB?
AE and EB, ma'am.
Now, yeah, which is more relevant for you? To prove
EB.
that is
EB.
EB.
EB. EB. Can you see EB here? See here,
Yes,
EB.
ma'am.
Yeah.
ma'am.
So half of AB is EB. Half of AB is EB is equal to what are the two halves of AC?
Yes.
AF and FC.
But which is relevant here?
FC, ma'am.
Yes.
Yeah. So EB is equal to FC. EB is equal to FC. I've shown this triangle first, children. So see here, EB, this one. EB is equal to FC. So the first thing is BC is equal to BC common side. Then AB is equal to AC. Half AB is equal to half AC. So EB is equal to FC. Next, one more.
Ma'am, angle BCF is equal to angle CBE.
Reason? What's the reason, Shreyas?
Ma'am, corresponding. Oh.
What do we know about what result we know in a triangle when two sides are equal? AB is equal to AC. What do we know? Somebody's mic is enabled. Please disable your mic. In triangle ABC, we know that AB is equal to AC. So when two sides are equal, what is it we have proved? When two sides are equal?
Ma'am, their angle also equal.
Which angles? When two sides are equal, in a triangle, when two sides are equal, then?
Said to be isosceles triangle.
Okay. What's the property? In an isosceles triangle, two sides are equal, then we have proved in a,
Two angles are equal.
which two angles? The angles opposite.
Ma'am,
The angles opposite to the equal sides. The angles opposite to the equal sides are also equal. The angles opposite to the equal sides are also equal. Okay, so I don't know the classes quite. So that means this angle is equal to this angle. Angle B is equal to angle C. That is angle ABC. Where is angle ABC? ABC, this angle ABC is also EBC. You can see this angle ABC is also EBC. 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 It's here. EBC is here. Is equal to EBC is equal to this angle ACB or FCB. 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 What's this one here? FCB is this angle. So what rule does it make?
SAS, ma'am.
SAS congruence criteria.
SAS, the two triangles are congruent. CP, CTC, we'll have BF is equal to CE. So BC is equal to BC, common side. Then another pair of equal sides, CF and BE, also given.
Ma'am, we can take another triangle too, ma'am.
Have we finished this one, Shreyas? So BC is equal to BC, common side. CF is equal to BE. How did we get that? CF is equal to BE? Because AB is equal to AC. Half of AB will be equal to half of AC. So like that we get BE is equal to CF. We needed one more equality. So in triangle ABC, AB is equal to AC. Two sides are equal. In a triangle, when two sides are equal, the angles opposite to them are also equal. So that way we have angle ACB is equal to angle ABC. Angle ACB is also FCB. See the figure. ACB is also FCB. FCB, which is an angle of this triangle. And angle ABC is also angle EBC. EBC, which is an angle of this triangle. So this makes these three equalities make SAS. So by SAS congruence criterion, these two triangles are congruent to each other. CPCTC, it follows BF is equal to CE. You can see both the methods here. This is what we just discussed. This one. Please go through this. Please go through the second method.
Ma'am, second method I came to say.
Yeah, but that time we had not finished discussing the first method, right?
Yes, ma'am.
Yeah. Now go through now. So the second method is using these two triangles. This is ABF. ABF and what's the other one? ABF and AEC. AEC. This is A, B, F. This is ABF. And this is A, E, C. Here, ABF has BF in it, has a side BF in it. And AEC has a side CE in it. ABF for BF, AEC for CE. The two sides which we need to prove are equal are parts of these two triangles. BF is of the first triangle, CE is of the second triangle. So if we can show that these two triangles are congruent to each other, then it follows from CP-CTC that BF and CE are equal. What is the information? What is this angle here? This angle, name this angle. This angle is BAF. BAF, this one, BAF. And this angle is CAE. CAE, it's the same angle. You can make out when you take up the two triangles, this vertex is common to both. This vertex is common to both. I have numbered that angle 1. So angle 1 is equal to angle 1. Then AB is equal to AC given to us. AB is equal to AC given to us. In the question, we already have AB is equal to AC. See here, equal sides AB and AC. AB is equal to AC. So angle 1 is equal to angle 1, common angle. AB is equal to AC given. Now AB is equal to AC. Half of AB will be equal to half of AC. Now take the other halves. What is half of AB? AE or BE? Half of AB is AE or BE. Let's take AE. And half of AC is AF or FC. Let's take AF. So like this, we have AF is equal to AE. AF is equal to AE. AF is equal to AE. So SAS rule, the two triangles are congruent to each other. See, one is angle A is equal to angle A, common angle. That's one thing. Then AB of this triangle is equal to AC of the other triangle. That's given to us. Now use the same information, AB is equal to AC, and take half. Half of AB and half of AC. AC is equal to AB. Half of AC is equal to half of AB. What is half of AC? Half of AC is AF or FC. But we'll take AF because it's a part of this triangle AF. Similarly, half of AB. Half of AB is AE or EB. Let's take AE. So half of AC is AF, half of AB is AE. AF is equal to AE. AF is equal to AE. So by SAS congruence criterion, the two triangles are congruent to each other. So the triangles are identical. C is equal to CF, CP, CTC. You can see it here. CE is equal to BF, CP, CTC. Any doubts, children?
No doubts, ma'am.
Okay.
No doubts.
Okay. Yes, children, look at this. I'll give you some time. Try to do it in your notebook and read it out for me. You must take up a triangle that has AD as a side and another triangle which has AE as a side. Show that they are congruent. And this result will follow. AD is equal to AE.
I
CP.
got two triangles.
Yeah, tell me.
Ma'am, triangle ABD and triangle ACE, ma'am.
Correct. ABD, ACE.
Ma'am, in this AB is equal to AC as they have given, ma'am.
Yeah, 1 minute. Let me just draw them. Okay, Shreyas, tell me. AB is equal to AC, right? Yeah, AB is
Yes,
equal
ma'am.
to AC. Yeah, that's given. Then let's ask somebody else. Thank you, Shreyas. Yes, continue with this. We have taken triangle ABD because it has AD in it. We have to show that AD is equal to AE. We have to show that AD is equal to
Can I
AE. No, not Shreyas again. We have to show that
Can
AD.
you also prove this using triangle ABE and triangle ADC?
Yeah, we'll do that also.
Okay.
Yeah. So in triangle, so we take up triangle ABD because it has AD in it. And we take up triangle AEC because it has AE in it. So we need to prove that AD is equal to AE. Okay. So AB is equal to AC. It's given to us. Now in triangle ABC, when you take up the whole triangle ABC, please see the screen properly. When you take up the whole triangle ABC, we know that AB is equal to AC. So that means the angle opposite to AB will be equal to the angle opposite to AC. Is this correct?
Yes, ma'am.
Yes, ma'am.
See, whenever you use this theorem in a triangle, when two sides are equal, the angles opposite to them are also equal. You must see only one triangle. You should not use this property as like this. Then you will say opposite to this side is this angle maybe. And opposite to this side, you will say this angle. See, you shouldn't see these line segments AD and AE in the middle. Then you would say opposite to AB is this angle and opposite to AC is this angle. It's not like that. It doesn't work like that. You must take up only one triangle. So that one triangle has three angles. Of those three angles in that triangle, two angles will be equal. So when you're using this property, draw the triangle separately like this and understand. So in this triangle, see this big outer triangle is ABC. ABC is this outer big triangle, ABC. So in triangle ABC, we know that AB is equal to AC. Opposite to AB is this angle C, not this angle, not this angle. And opposite to AC is this angle B. So when these two sides are equal, these two angles are equal. Now, where are those two angles? These two angles are equal. This angle is equal to this angle. Because when you're using that property, you should ignore these lines that go in the middle. You should ignore these lines that go in the middle. So opposite to this side is this angle. Opposite to this side is this angle. And these are the two angles that are equal, which means angle B here is equal to angle C here. Because this one, this angle is a part of ABD, is a part of ABD. And this angle is a part of AEC, AEC. So like this, we have another equality. Angle B is equal to angle C. Now, for the next one, take up this equality given. BE is equal to CD. This is given to us. BE is equal to CD is given to us. Subtract DE from both the sides. See here, BE, which is BE, this is BE, is equal to CD, is equal to CD. Okay, let me write that. See, let me write BE. Let me write BE is equal to CD. Is this given, children? Is
Yes,
this
ma'am.
given? Okay.
Yes, ma'am.
Now, okay, let me tell you in a different way. Now, split BE. How can you split BE?
BD plus DE.
Yeah, BD plus, let's write BE as BD plus DE. DE. And how do you split CD?
DE plus EC.
DE plus
EC.
EC plus EC. Now what happens on both the sides? DE gets cancelled. So we have a new result. BD is equal to EC. BD is equal to EC. We have a new result. BD is equal to EC. And see here, BD is equal to EC. So what is the rule? By which rule are the two triangles congruent?
SS.
SAS. SAS congruence criterion. Triangle ABD is congruent to triangle ACE. AD is equal to AE, CP, CTC. Just check. Written both the methods, ABD, ACE. You can also see the alternate proof. Tell me again, what are the equalities we listed in the two triangles?
AB is equal to AC, ma'am.
Ma'am, AB.
Okay, AB is okay. Hitesh, tell me, AB is equal to AC, then
B is equal to C, ma'am.
angle B is equal to angle C.
Yes, ma'am.
Okay.
And BD is equal to EC, ma'am.
Explain how we got that.
Ma'am, we separated, they gave that BE is equal to CD, ma'am. We wrote BE as BD plus DE, ma'am. And we wrote CD as DE and EC, ma'am. We cancel out that DE in the both the parts, ma'am. So we got BD is equal to EC, ma'am.
Very good. So by what rule are the triangles congruent?
SAS.
Now name the triangles. The correct order. Triangle.
Ma'am, triangle ABD and triangle AC.
ABD. Triangle ABD is congruent to triangle AC.
ACE.
Yeah, ACE. So CPCTC, we have AD is equal to AE. AD is equal to AE, CPCTC. Okay. Now you can also take up triangle ABE. ABE. You can also take up the triangle ABE and triangle ADC. ABE, and you can take up the triangle ABE because it has ABE has AE in it, and the triangle ADC which has AD in it. Now tell me the equalities here.
Ma'am, AB is equal to AC, ma'am, given.
AB is equal to AC given. AB is equal to AC given, correct.
BE is equal to CD, ma'am. This is also given.
BE is equal to CD. Yeah, correct. It's directly given then.
B is equal to C, ma'am, because two lines are equal, so the opposite angles are also equal, ma'am.
Because in a triangle, when two sides are equal, the angles opposite of them are also equal. Correct, correct. So Hitesh, angle B is equal to angle C. Angle B is in this triangle ABE and angle C is in this triangle ACD. So angle B is equal to angle C. What's the rule?
Ma'am, in an isosceles triangle, two sides should be equal, so two angles should also be equal.
Correct. What is the congruence rule?
ASM.
What's the congruence rule?
SAS.
Yes, side angle.
SAS. Side angle side.
SAS congruence criterion, the two triangles are congruent to each other. Therefore, AD is equal to AE. AD is equal to AE, the third pair. This one, AD is equal to AE. AD is equal to AE. And that's what is here. Take a screenshot. See that first method which we discussed, you can also proceed like this. Subtracting DE from both the sides. You will understand this. You can either split BE or you can subtract DE from both the sides. See here for BE and CD, for BE and CD, you can write BE as BD plus DE and you can write CD as CE plus ED. Or you can subtract DE from both the sides, like what you see here, subtracting DE from both the sides. On Wednesday, during the class, we'll have a test on number systems. In number systems, exponents. We have different parts, no, in number systems.
Yes,
So
ma'am.
we'll take up a test on exponents, only exponents.
Today, ma'am.
The next class on Wednesday.
Okay, ma'am.
During the next class, not in the portal. During the class, there will be a test on exponents. Maybe you can also go through rationalizing the denominator. These two topics.
Okay.
Rationalizing the denominator and exponents.
Yes, ma'am.
Okay. Okay. Took a screenshot, children?
Yes, ma'am.
Yes, ma'am.
Okay. In an isosceles triangle ABC, AB is equal to AC. In an isosceles triangle ABC, AB is equal to AC. Okay. Isosceles triangle ABC, AB is equal to AC. All right. The bisectors of angle B and C. These two sides are equal, okay? The bisectors of angle B and angle C intersect each other at O. This is angle B. So then this will be the bisector of angle B. This is angle C. Then this will be the bisector of angle C. The bisectors of angle B and C, they meet at O. They intersect at O. Join A to O. Join A to O. Understood the figure, children?
Yes, ma'am.
Yes, ma'am.
Okay. So we need to show that OB is equal to OC. We need to show that OB is equal to OC.
Ma'am, I have a guess, but I don't think it would be right.
Yeah, tell me.
Ma'am, as they have given that ABC triangle ABC is isosceles with AB is equal to AC, ma'am.
Okay.
So, ma'am, they are also given that angle B, bisectors of angle B and C intersect each other at O. So, angle B is equal to angle C, ma'am.
Why is angle B equal to angle C?
Ma'am, because by isosceles that isosceles rule that if two angles are equal, then two sides are equal, then two angles must be equal. In that angle B is equal to angle C.
Correct. Angle B is equal to angle C. Correct. Next.
Ma'am, then half of angle B is equal to half of angle C. Is this correct?
Correct.
Ma'am, by that half of angle B is equal to angle OBC. I have just taken it as angle 1, ma'am.
Which are the two halves of angle B?
Ma'am, that is in this diagram. OBC, ma'am.
Which are the two halves? Name the two halves of angle B.
Ma'am, angle OBA and angle OBC, ma'am.
OBA and OBC. Okay. Yes, Shreyas, you're right. So children, it's like this. In a triangle, we know that when two sides are equal, the angles opposite to them are also equal. So since it's an isosceles triangle, since the triangle is an isosceles triangle, and we are given that AB is equal to AC, the angle opposite to AB, that is angle C, will be equal to the angle opposite to AC, which is angle B. So you know that angle B is equal to angle C. Half of angle BC, you can take half only when the angle is bisected. And here the angle is bisected, so you can take half. Half of angle B will be equal to half of angle C. See, angle B is equal to angle C. Half angle B is equal to half angle C. Half of angle B, 1 is half of angle B, 2 is also half of angle B. Half of angle B, half of angle C is 3, or half of angle C is 4. Angle 1 and angle 2 are the two halves of angle B. Angle 3 and angle 4 are the two halves of angle C. Angle B is equal to angle C. Then half of angle B will be equal to half of angle C. So half angle B is 2, angle 2. Half angle C is angle 4. Angle 2 is equal to angle 4. A new result. Angle 2 is equal to angle 4. So in triangle OBC, if angle 2 is equal to angle 4, that is when two angles are equal, the sides opposite to them will be equal. In a triangle, when two angles are equal, the sides opposite to them will also be equal. So since angle 2 is equal to angle 4, OB is equal to OC. And then to prove that AO bisects angle A,
Ma'am, for that first we have to prove that triangle AOB is equal to triangle AOC, ma'am.
yeah. But to prove that AO bisects angle A, AO bisects angle A, that is, we need to prove that angle 1 is equal to angle 2. I've marked 1 and 2, I've marked somewhere else here. Ignore that. So this angle 1 and angle 2. If you prove that angle 1 is equal to angle 2, that means AO bisects angle A. Go through the proof. So for that, you will have to show that these two triangles are congruent to each other. To CPCTC, you will get angle 1 is equal to angle 2. If 1 and 2 are equal angles, that means AO is the bisector of angle A. If 1 and 2 are equal angles, that means AO is the bisector of angle A.
Ma'am, in CPC congruence part of corresponding triangles, I get OAB is equal to OAC, like that I'm getting.
Yeah, you're right.
Ma'am, why that AO bisects angle here, ma'am? Because
Yeah, correct. Once the triangles are congruent, CPCTC, angle 1 is equal to angle 2. That means AO bisects angle A.
okay.
Children, please go through the proof.
I'm finished copying.
All right. Any questions, children?
No doubt.
No doubts, ma'am.
No doubts, children?
No doubt.
No doubts.
No, ma'am.
You're sure you understood when you show that these two triangles are congruent to each other? Angle 1 of this triangle will be equal to angle 2 of this triangle. If angle CPCTC. So if these two angles are equal, it means AO bisects angle A. AO divides angle A into two equal halves. That's why 1 and 2 are equal.
Ma'am, for this question we have to prove no, ma'am.
Yeah, we'll discuss this in the class now. Yeah.
Ma'am, I got the answer.
Me too, ma'am.
Okay, somebody else, not Hitesh and Shreyas this time again. Somebody else, children. I'll come back to both of you in case nobody answers. Class.
Ma'am, can I?
Yes, Sangmitra.
Yes, ma'am. AD is in triangle ADB and triangle ADC.
Okay.
AD is the common side, so it's equal.
Okay.
Angle ADB in triangle ABD is equal to angle ADC in triangle ACD since it's 90 and it's
That
given.
means angle 1 is equal to angle 2, right?
Yes, ma'am.
Okay.
Then BD is equal to DC in triangle ABD and ADC respectively.
Okay.
Since
Why BD is equal to DC?
since it's AD is a perpendicular bisector now.
Yeah, it's a perpendicular bisector. Very good.
So
Okay.
triangle ADB is congruent to triangle ADC by SAS rule.
Okay, correct.
Now AB is equal to AC by CPCD.
Very good. Perfect. Yes. So AD is the perpendicular bisector of BC. AD is not only perpendicular to BC, it also bisects BC. AD is the perpendicular. bisector of BC. It's perpendicular to BC, it bisects BC. Perpendicular meaning it makes 90 degrees with BC. AD is perpendicular meaning AD makes 90 degrees with BC. AD makes 90 degrees with BC. AD is the perpendicular bisector. That means AD makes an angle of 90 degrees with BC. And also AD bisects BC. AD perpendicular to BC means AD makes an angle of 90 degrees with BC. That is, angle ADB is 90, angle ADC is 90. Now AD bisects BC. BC is a line segment. It bisects the line segment. That means D is the midpoint. AD bisects BC. So D is the midpoint. That means BD is equal to CD. BD is equal to CD. So see, in the two triangles, when you take up the two triangles, this is the common side. This angle 1 is equal to angle 2 is equal to 90 degrees and BD is equal to CD because AD bisects BC. So BD is equal to CD. SAS rule the triangles are congruent. CPCTC you will have AB is equal to AC. This is a simple one, children. You cannot have any doubts with this.
Yes, ma'am.
Yeah.
I'm finished writing.
Yeah. For what? Yeah, go through all this, take a screenshot. You can see the question also. Take a screenshot of this one, go through the proof. This one. Take a picture of this. Am I audible, children?
Yes, ma'am.
Yes,
Okay.
ma'am.
All right. I said take a picture of this one, this one.
Yes, ma'am.
Okay, this, go through the proof. And then this one also.
Yes, ma'am.
Yes, ma'am.
Okay. This one.
Yes, ma'am.
Yes, ma'am.
All right.
Yes, ma'am.
Take a picture of this one.
Yes, ma'am.
Completed.
Yes, ma'am.
All right. Yeah, this one.
Completed, ma'am.
Yes, ma'am.
Yeah, and this one.
Completed, ma'am.
Yes, ma'am.
Ma'am.
Yes.
All right, children. All right, children. So that's it for today's session. If you have any questions, please stay back. Else you may leave the meeting. Thank you.
Thank you, ma'am.
Thank you,
Thank
children.
you.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you. Thank you.
Thank you, ma'am.
Thank you, children.
Ma'am,
Yeah.
I couldn't attend the class yesterday. Can you send the recording?
Yeah, sure, sure.
Yes, thank you.
I'll do it in some time. Yes. Yeah.
Thank you.
Yeah, thank you.